I did it again. Why do I keep doing this to myself? Broke one of the brackets. Let's see if this works. This is a 13-hour print. I built another complex robot, and this build was even tougher than the last. After all the troubles I had from the last project, I decided to take a break from this robotic hand and get back to the basics. Why am I tackling such a complex project when I'm just a beginner? It's time for me to revisit the Arduino kit. Don't worry, little buddy. I'll revisit you soon. Psych! That's a stump double. Why would I throw the original? Why would I throw the actual hand? But I do need to change gears for a bit. I know what I'm gonna do. How about I make this Arduino starter kit project a bit more interesting? What if I turn this kit into a fully functional robot? All right, first I need to grab all the electronic components that makes up the Arduino kit and categorize them outside versus inside. The project list in my particular kit is as follows. You know, we got the hello world, blinking light, PM monitor, traffic light, blah, 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 blah. This is what we have. This is the inside group. This is the outside group. We also have our microcontrollers. We have our power bank right there. We have the PWM, the shield, and the Arduino microcontroller, R3. Right there, boom. We're gonna put all these things to the side because we're not worried about that right now. And we're focusing on this. This is the ultrasonic sensor, fan head that might go on the top of the bird, LCD display, LEDs, a controller. Although I might program my own controller, motion sensor, LED modules. Boom. These are all the things that are going to go on the outside. So now I just need to measure everything, get all the dimensions and sizing of everything so I can implement it into my design of the bird. So I went ahead and modeled all the electrical components and made a sample test block. The print is finished. Dang, I forgot to make a slot for this. Of course I'll forget something. That looks like that fits through there. Ooh, perfect. The LED fits. That fits even though it's not as tight. Oh, wow. That has too much space up there, so I need to definitely take that down a bit. DC motor. That's a good fit. We're looking pretty swell. Put a servo in there. I know the servo fits because that was one of the earlier things that I made, but everything fits pretty good. So I came up with this simple, easy, two-legged bird sketch. Easy peasy, simple. Nope. See, I thought I had a simple bird design, and then all of a sudden I get this strange voice in my head. I don't know where this voice came from, but it was like, it has to be able to walk. How you gonna make a robot that can't move? Okay, now we're adding multiple joints and motors. That should be good right there, right? Nope. Oh, what if it can drive as well? Yeah, that'd be awesome. Okay, we'll add some hidden wheels to the bottom. Easy, right? Wait a minute. The bird has to be able to grab things. It most definitely needs to be able to turn left and right. All right. More motors, more moving parts. Another complex build, and that's not even mentioning all the electrical components from the Arduino kit that has to go inside the robot. That has to be a functional part of the robot. Why do I keep doing this to myself? All right, this is my designing of the bird. I don't like this. This is my animatronic Arduino bird design that I've come up with. So I'm going to start building this in Blender. This time I decided to split the body into two sections and attach them by screws. That way, if one part fails during the printing process, that'll only be a 2-hour fix opposed to an 11-hour fix. Anybody got time for that? I'm just building the frame, the inside, figuring out the placements of the joints. This section right here, I have it broken down in two sections. This is one section I have. This is the second section that I have to print for the base. So I sketched out the bird, and now it was time to build the physical version. And boy, did everything go so smooth. Everything printed so smoothly. This time around, my machine printed each piece flawlessly, and I had no problems. All right, so first piece is complete. This is the foundation, the base of everything. This is actually going to hold the power bank. And strapping it down with the zip tie. Psych! I ran into so many problems. And I don't mean so many problems. I mean so many problems. So I get the first plate printed. And now I'm moving on to the second part of the base. And what do you know? A jam. Yup. My nozzle gets clogged. And I don't want to hear all y'all jumping in the comments talking about, your machine sucks. My machine never gets clogged. That would never happen to me. I've had my machine 40 years and I've had perfect prints for 41 years. If I had a single problem with my machine, I would throw it in the garbage and buy a way more expensive machine. My 3D printer holds my hand and tucks me in bed every single night by 7:30. Me and my 3D printer just got married. We have 3 kids and one is now on their way to college. Good for you. Here's a cookie. Huh. Eat the cookie. Eat it. But I'm not trying to hear your perfect fairy tales about how great your machine is, how my machine is bad. My machine is perfectly fine. And I'll prove it. Look at that. Come on, you got to give it to me. I'm so proud of myself. I troubleshooted this and got rid of the jam. We have problems, but it's not the end of the world. All we got to do is research, educate ourselves, and, well, so much for that plan. Let's try it again. Look at him. He really acting like he printing something. Look at him go. Man. It's funny now. I cannot make this up. Look at this. Look at this. Back in action. Sheesh. Spoke too soon, huh? Jeez Louise. The filament got stuck, jammed in here some kind of way. I'm starting to think it's this yellow filament. Why everything started getting jammed since I started using the yellow filament? I don't know. It's literally jammed inside that area right there. Like I told you, once I learned how to clean out, oops, I need to be careful. Once I learned to clean this out, it said nope. See, it realized that I figured out how to clean this out. So it said I could do something better than that. So now it said I'm going to go ahead and get jammed in this part. I pulled out the smallest Allen wrench that I had provided in my kit right there. And I just stuck it through that hole right there. And I was able to push the filament through. Since I have everything taken apart anyway, I decided to go ahead and do a full maintenance clean. When I bought this machine, I watched a lot of videos before I bought it. And also after I bought it to see how to properly care for the machine. So don't think I just bought this machine without doing any research. I'm too old for that. I'm just doing a full wipe down the machine. I'm going to re-grease everything and re-oil the rods and all this kind of such. Getting that oil on there right quick. Got the rods greased up. I'm going to move the plate up and down just to distribute the grease. Okay. Enough with all the cleaning. Let's get back to the project. Another one down. Might just try a different color. Why? Probably need to just go back to white. Yep. So first thing I did was jump online looking to solve the problem. And I started to develop a theory that maybe, just maybe, it's the color of the filament that's causing me problems. I kind of touched on this in my last video, but this time I decided to actually investigate it. See, when I would use yellow or green, I would have problems. Maybe the filament's not sticking, or I would get a clog. Like I started getting clogs when I started using yellow. But whenever I used the white filament, smooth sailing, no problems. Tugboat, right? Tugboat. I have a background in art and working with fabric, so I know that different color pigments can physically change the quality and properties of a material. Now also, because the Elegoo Centauri carbon is a really fast machine, it tries to build the next layer before the filament has even had a chance to cool down and adhere to the mat. It's literally laying down new plastic while it's ripping up the old plastic. So the solution is to slow it down, not the whole print, just the first layer. That way it gives it time to stick and adhere to the mat. I got it on snail mode. It's going super slow. but it's laying down the filament. All right, let me stop talking before we go wrong. Look at that print. Y'all mad. You mad. You see it. I figured it out. I figured it out. And as you can see, my calculations were correct. It's just to test my theory. So I believe I figured it out. Let's see if this works. This is a 13-hour print. Moment of truth. The light is off. But turn light on. Uh-oh. Nice. Nice. Told y'all I figured it out. I figured it out. Problem solved, right? Problem solved. So I am constantly learning, and I'm here for it. Back to the project. Oh, wait a minute. What printer did you say you used again? Train. By train. Accidentally cut the power to the machine. Wow, it picked up where it left off. Cool. After weeks of designing, calibration errors, and fighting my own machinery, the frame of the Arduino animatronic bird is now complete. These are the legs. These are where the servo is going to go. So we got 1, 2, 3, 4, 5, 6 servos so far. I'm going to put these together, but we have more servos, but these are the legs. Got the microcontroller and power bank attached to the base, and with a simple code, we can run some tests. So the servos move fine. Now I'm going to attach the base and see how it holds that up. I'm going to redesign because I'm learning that I need to add the... Long story short, the 9G servos are not strong enough to support or hold the weight. Therefore, I need to transition to bigger servos such as the 996R. These were too weak and they weren't strong enough, so I had to redesign them. Damn! The big boy servos. I'm going to redo this design to make it a bit more efficient. This is a lot of weight to be on each leg, and I think I can eliminate some servos or redesign it where they're in a better position so it's not as heavy. If you let all the weight hang like that, look at that, that's a lot of weight. It's as if it wants to snap. I simplified everything, made everything a lot more sleek, I guess. See, in this original design, we had a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 motors. I was able to simplify it a lot better and bring it down to 7 motors. So I was able to get rid of 3 motors and eliminate some of that weight. All right, this is another design that I made. I'm just going to share my bad designs as well. So I thought doing this, and I thought changing the joints to make them to have them controlled by wires, but that's not going too well. So and now comes the real test, making this thing walk. Woo, it's hot out here. You see all this sweat on me? Can y'all see the sweat? Woo! I'm about to go to the gym. I'm about to go to the gym anyways. I ain't tripping. Man.